Welcome to the course of data science. In unit 2.2 we will discuss about data collection, and definitely it is one of the very important concept, that how we will collect our data, what are the possible sources of data through which we can receive or through which we can collect data. And prior to starting the today's lecture, I would just want to recall about the last lecture, which is actually unit number 2.1, about data types. So if you remember, in the last lecture we were talked about structured data and unstructured data. And unstructured data, I have talked about like text documents, your email, your messaging, like maybe SMS or maybe WhatsApp message or anything like that. And if you talk about structured data, and we have talked about anything which are basically an associated schema which actually define the data itself. We also use the term metadata, data about data. So one thing which you have your data, and there's another data which actually explain or describe your data, and we call it as a metadata. Okay, so this is the requirement that the structured data has basically associated metadata. So for example, if I just open over here, that this is a tabular structure or a table structure in which you have around 9 columns, 1 2 3 4 5 6 7 8 9 columns. One column is customer ID having numeric values, other is sex, which has with the character value, either male and female, or female is employed, not applicable, true, false, something like that, income, numeric, and so on. So this is actually the data, and the metadata actually describe that it should contain maybe numeric values, it should contain character value, it should contain maybe boolean or not applicable or null, for example, and something like that. So it's a very well defined structure. This is data, and definitely there is associated metadata which actually describe that what are the names of the column, what are their data types, whether it's null allowed or not allowed, and any other constraint. However, if I can just scroll down, if you just look into these two columns I'm highlighting over here, if you can just look into these two columns, then you can realize that this is unstructured data. Okay. For example, in this paragraph we have several data points, something like this, they are not clearly labeled. If we were to do some processing as we did in something like this and so on. So what the problem? Humans have no difficulty understanding a paragraph like this that contains unstructured data. But if you want to do a systematic process of analyzing a large amount of data and creating insight from it, the more structured it is, the better. Okay, so definitely human can read it and somehow interpret it, somehow understand it, but it will be very difficult for machines to understand it. And that is why previously organizations ignore unstructured data for data mining or basically maybe analytics or something like that. But now with the advancement of technology as well, we are able to cope up with this problem, and that is why organizations are now incorporating structured data, unstructured data along with the structured data for their analytical processing, for their decision making, for their data science activities. So let's move to the slide. So after discussing about some example from unit 2.1, which is about structured and unstructured data, now we should move to the current unit, which is about data collection. So how we can select data? What are the possible sources of data through which we can actually find out or through which we can get the desired data in which we are actually interested. So there are a lot of places that host shared data online, or you can collect them yourselves. Of course, your system is also producing data, or maybe if you have OLTP systems or any other basically communication system, maybe, or maybe something else. All of them are actually producing data. So you have your own source of data, then you have basically data available via other resources, maybe from internet, from some government agencies, from some market survey companies, or some market survey reports. Okay, and there are many sources. Okay, so you can select, you can collect all your. For example, just take an example of Twitter. Maybe you are actually interested in some getting some data in which you are interested. You might be looking for some hashtag, and you can grab your data based on those hashtag from the Twitter stream. So this is one of the examples that you can collect. For example, if your product has its own hashtag and you want to have some insight about what are the opinion or what people are actually posting about your product using maybe your hashtag, and you can simply grab this information from the Twitter stream. So they are basically many things. You know it very well, as we have discussed in this section in the chapter 1, that if you are doing machine learning or data mining or maybe data science, you can get data from Kaggle to experiment it, to learn about it, to basically to practice. And might be some of the data which you are getting from there might help you in your maybe in your organization as well. Okay, and then Google data as well. There is option or the search option available on the Google, through which you can search the data. And there are many other organizations which we will be discussing about it in the later slide, when we are actually when we will be actually working with the actual data, making models and analyzing it. Okay, so there are many sources of data. You might request some other organization to perform some survey on your behalf. Okay, because that organization is basically specialized in doing surveys. So in that case, you will be requesting, for example, that organization to perform surveys, and you will get the data from them and incorporate into your overall data science process. Okay, so there are many ways through which you can collect data. You can sometimes you might buy data from some other organization, some independent organization that might survey. That might perform surveys, and they might perform surveys relevant to your organizational domain, or the area in which your organization is producing products. So you will be using external data along with your own data to have a holistic view of the data, or the insight, or the holistic view of the insight from these data. That is why you need data, and there are many sources of data. For example, many organizations in IT like Gartner publishes different reports, different predictions. You might get those reports, and that might be beneficial for your own organization, or for your own analysis, or for your own data science process. So there are variety of sources available through which you can receive, through which you can get data to perform data science process. Okay, so there is another data which is actually known as open data or open data collections. And open data collections has several characteristics generally. For example, public. So in public means definitely the data actually available to you, but that might have some restrictions, some privacy, some law, some confidentiality constraints, etc. Okay, so data is actually available. You might use it, but you have to as a study you have to basically first need to make an understanding that is there any restriction for which purpose I can use, or for which purpose I cannot able to use this data, something like that. So it is actually public, it is actually available, but again you have to check constraints like privacy, like security, like confidentiality, or any other restriction. And if it is okay for you, if it is fine for your use, then you can get those data to perform your own analysis. Then of course it should be accessible. It would be available, easily accessible to download, okay, in a format which is very convenient for anyone to use. It should not be in a proprietary format. And if it is in a proprietary format, then you are bound to use a particular software to read that particular data, and that will be not beneficial for you. Okay, so in open data, we expect the data should be available in accessible manner, in accessible format. Like maybe there is a public repository from where you can download it, and after download you can easily access, because it is available in such a format that that anyone can read it. Or you can develop your own parser, or you can develop your own source code to read that data, but it should be in a well standard format that anyone can use it. Okay, so after that, described. This is very important, and I've already explained about it if you can recall it from the previous lecture, or even I have talked about in the start of this unit 2.2. Okay, so described, how a data can describe, how you can describe a data. Okay, so if a data have metadata, or what is metadata? Data about data. So if your data has basically an associated metadata, then it will be very convenient, then it will be very easy to understand, to know about what this data is all about, what different attributes, what different columns might be representing, what different number is actually representing, what the meaning of some text over there. Okay, so there should be some associated metadata. So this is the requirement. So open data must have described characteristic. If it is not described, you cannot able to understand. If you cannot able to understand, how you can able to use it? How you can incorporate this data into your own data science process? Okay, so it is very important that your open data must have. If someone is claiming that this data is open data, then along with the public, accessible, it should also be described. Okay, so reusable. So what is the meaning? If you are a computer scientist, you know it very well, the term reusable. If you just recall, we extensively use the word reusable in object-oriented programming. Develop once, and then we can use it as many times as we want, as we need. Okay, so what is here reusable? Means the data is actually available, other can reuse it. But is there any licensing over there? Is there any restriction? If there is some restriction, if there is some licensing, that it means it's not open. So open data must be available under some open licensing. Otherwise, we cannot able to call it open data. Right? You might be confused that in public we have talked about some security. In public we have public and reusable are two different things. Public means it's accessible, but there might be some constraint, might be some privacy constraint or something like that you just need to follow or fulfill those requirements. But you can use it. Nobody is actually stopping you. But in the reusable, it is actually sitting under what license it is actually available. Okay, so this is actually reusable, and it should be open license, by the way, right? Okay, then actually complete. Open data are published in primary forms in the another very important thing, finest possible level of granularity. Okay, of course, if there is a restriction from government law or something like that, you might need to basically decrease the granularity. You might need to actually need to aggregate or something. Maybe you have to go from from fine level to some high level. What is the meaning of it, by the way? Let me explain. Complete means the data is in the form as it was collected. Means nothing is basically combined. Okay, nothing is actually combined or maybe aggregate, but at the same level at which it was actually collected. So for example, if you have collected the data, maybe just take an example, if we have basically collected data of individual product, then complete means it should contain data of individual product and individual transaction. If you have collected data of individual transaction about a product, then it should be available at this level, means individual transaction of all products or individual transaction of products. Let me explain. If somehow basically I have combined maybe all the transactions amount or something like that of each individual product, then this means it is not in the same level, or it is not anymore at the fine granularity level at which I have collected the data. So I hope now it's clear that at whatever level we have collected data, it should be available at the same fine level, rather than basically we can reduce its level. Maybe we can perform some aggregate. If we can perform aggregate, definitely we have computed aggregate from the same data, but we have missed the details because we have combined it. It is okay that you might have computed some aggregate, or you might have combined multiple record or multiple data into one, but even in that case, the actual data should also be available along with the aggregated data, and so on. So this is the meaning of complete, that the data should be available at the same level, at the same fine level at which we have collected the data. Okay. Timely. It's again very important, because time is very important. If you are publishing open data and it is actually from 40 years past or something like that, and it does not make any sense to use in the recent time, then it is not actually fulfilling the requirement. The data should be available as soon as it is collected, so that people can use it timely for the very recent analysis. Okay, so open data are made available as quickly as necessary to preserve the value of the data. Frequency of release should account for key audiences and downstream needs. So that's the motivation. that it should be made available as quickly as possible. So in other words, as soon as you have collected, you must provide it, you must publish it, so that other can take benefit in a timely manner. Okay? So the last point about open data is manage post release. Okay. So what is manage post release? It means once your data is actually released to others, to public, it should be managed after release. Means the support should be available. If anyone has some ambiguity, some critic, some issues with the data, someone must be available, or the data or the organization or the person who have actually published the data, some data must designate someone. Maybe he can himself basically support, otherwise they should designate someone to provide support for the data, to answer query relevant to the data, to answer concerns raised by others. That is the motivation. So these are characteristics of open data. I hope it is clear to you. Let's move to the next point, which is actually social media data. I don't think it need very much. It needs detailed explanation. Why? Because social media data is the primary source of data that we all are using day to day, on a regular basis. Okay, on a regular basis. We all uses Facebook. We all uses Twitter. We all uses many other social media platforms. So these social media platforms are very rich in data. You can fetch data about many things in very diversified formats, from hypertext data to image to video, okay, and even even in a structured format. Maybe some JSON data, we will talk about it. Maybe XML data along with some associated XML schema. Okay. So the point is basically social media data is these days very popular, and on a day-to-day basis a huge amount of data is actually produces by the user of the social media. So social media the company which actually running the social media generally does not produces its own data. However, the user or the subscriber or the person who have basically account with the social media are contributing data. That is why it is very meaningful, it is very beneficial for many purposes, from maybe law and order situation to maybe product, to basically election campaign, to many others, to know about the sentiment of the nation, about sports, about any pandemic like COVID. We can get data from social media. They are basically these all social media websites provide some sort of APIs through which you can receive data in various formats like JSON, JavaScript object notation is actually JSON, and XML format, extensible markup language. Okay, so automatically you can fetch data using this API. You might heard about the very popular API of Facebook, which is known as Facebook Graph API, which you can use it. Okay, so they are, again, it's for Twitter, there are libraries and there are different ways, and even for a single platform there are multiple ways via which we can select it. Even they are basically concept of independent organization. They have basic contract with the social media websites, and they sell data. They sell your desired data. Okay, so these are basically, but again they need to fulfill the privacy, security and other policies or the restrictions. Okay, so this is basically social media data. Then about multimodal data. Here the multimodal means you are actually collecting data for same purpose from different sources or different output. Let me clear one thing. Let's take an example of IoT, Internet of Things. There are various sensors and you are collecting data from various sensors and somehow combine to perform some type of analysis. Like you are getting data from temperature sensor, you are taking from pressure sensor, you are getting data from some motion sensor and so on. So from different output devices you are getting data for one single motivation or one single purpose. Let's take another example to explain about multimodal. In various contexts, we may need to collect and explore multimodal. Here, multimodal is actually different forms. As I explained that about the IoT, that temperature sensor, pressure sensor, maybe motion sensor, something like that. So take another example. So you are getting data in different forms, maybe like multimedia data, maybe in the form of images, in the forms of audio, in the form of video and so on. Maybe if you are basically you have an IoT system for city surveillance, so in that case you are actually might be getting audio, video or maybe something else. Let's take another example. One of the well-known applications of such multimedia data is analysis of brain imaging data sequences, where the sequence can be a series of images from different sensors or a time series from the same subject. The typical dataset used in this kind of application is a multimodal phase dataset, which contains output from different sensors such as EEG, MEG and fMRI on the same subject. By the way, subject, I'm talking about a person in this current situation and in this current example, subject is actually the person and we are actually trying to get data about that person. So this is a subject and we are getting data like EG from EG, MEG and fMRI. Okay, so within the same paradigm. Okay, so this is basically an example of getting multimodal data for analysis purpose. So maybe if you want to observe the brain activity of a subject, again in the here subject is a person or maybe a patient, so we are not only getting from one source or a one type of data, but here we are getting data from three different sources, having three different types, but the motivation is same, but the goal or objective is one. We may want to basically study the brain pattern of that particular person. So in that case, this is a multimodal data. Why? Because we are getting data from different devices having different representation of data, different structure of data. Okay, so we are getting from EEG, we are getting from MEG, and we are getting from fMRI. So this is about multimodal data. Let's move towards the next slide. The next topic in this unit, which is actually unit 2.2, is actually structured data file types. So we do have basically these different file formats in which we can store data, and you might be thinking about that why only 5 different file types are written over here, why not others, because there are plenty of file types. So if you can recall about from the topic of open data, and we ever talk about that the file formats should be in a convenient format so that anybody can read it. So these are the common file types which are very easy to understand by any through any software, or maybe you write your own program to read it. And these are the very common file types to exchange data from one organization, between different organization, from one application to another application, and so on. So first of all, we should talk about CSV, or comma separated version. It is a very simple file structure in which each value, or you can say value belongs to each individual column, will be separated by comma. If you have, let's take an example. If you have 3 columns, or you want to store data about 3 columns. One is name, second is father name, and third one is, for example, CNIC number. Okay. So generally in first row of CSV file, we write the name of the columns, followed by one or more rows in which the actual value contains. So in this case, name, comma, father name, comma, CNIC. This become the header, or basically the column name, followed by the values. For example, name Amir, comma, father name Kashiv, comma, some CNIC number, some valid CNIC number, or something like that. This is CSV. So let's take a concrete example from book. Maybe this is an example of CSV file. You can see over here. This is 1, this is 2nd, this 3rd, and this is 4th. Okay. So now we have 4 attributes. You can treat this as a header. Means this is first column, second column, third column, fourth. All of them are actually separated by comma. Then you may have one or more rows. Treat, value is no treatment. Before, value is 13. After, value is 16. Difference, value is 3. Then again, no treatment. The value of treat is no treatment. The value of before is 10. The value of after is 18. The difference is actually 8, and so on. So this is basically a very simple file structure, and it is used by many softwares, and it is very easy to basically create, and it is very easy to exchange data between different organizations, or even between different softwares. Okay, there are again there are some disadvantages. For example, like if you have comma in the data itself, then how you will be represented, because if you have address like a comma 18, so if you declare here, it become a as one column, 18 will become second column. So this type of problem will arise. However, there are solutions, like if you have a comma in a single column value, then you might enclosed in double quotes. Okay. So again, CSV is very simple and easy to handle file structure, but in comparison with many other file formats, it's less powerful. Even in fact, you can create CSV file in Microsoft Excel or any other spreadsheet, or you can save your Excel sheet in CSV as well. Right? The next, which is very similar to comma separated version, but having a different way to separate column, is actually TSV, or tab separated version. In this format, we basically create multiple columns by using tab character. You know that in keyboard there is a tab character we represent generally in programming as \t. So after each column value we press tab and then we can start another value of the another column and so on. The advantage of basically tab is actually unlike comma, which has basically its meaning in the data itself. So if a data itself contain column, then it create problems in comma separated version, and that's why I told you that one way is to basically enclose that column value into double quotes. But here you are not using comma, and if a column value contain tab, then we can easily eliminate or remove or replace with space, and it does not make any big difference, or in general it will not create any problem. Unlike if we can remove comma from the comma separate version file, I mean if a value contains comma and you are storing in a comma separated version file, and if you want to replace comma, then it actually loses the meaning of the value, because the comma is actually an important thing and might be representing that one thing is actually ended and there is something which is associated with the first but having different thing. That is why we can not able to remove or ignore comma in a particular value in CSV format. However, if a tab contain in a value in tab separated version, then we can easily replace or remove with space. The third format is actually XML. Let me take an example of CSV, not CSV. This is actually tab. So mind it should not be written like this, tab or tab, but actually after writing name, you have to press tab key in your keyboard, then you can type age, then press tab, then address, and so on. Similarly, in the values, this is actually the header or the column titles or the column names. Then basically the values, again one value, then press tab, then second value, then press tab, and so on. So this is a general file format for tab. So after that, XML, Extensible Markup Language, also known as Universal Data Language, very popular and very frequently used for and it is not only easy to understand by the humans, but also it is also very easy to understand by the machines as well. There are many basically standards developed by W3C to further strengthen XML, like DTD, document type definition, document type declaration, or XML schema to create a robust schema, or to associate metadata with your XML data. So there are many other things. There are also some other technologies associated with XML. XML is there are many advantages of XML, but XML is actually verbose. It's too space hungry. Even if you want to write a single value, you have to enclose in a tag, and tag has basically many characters, and then you have to close a tag as well, because remember, XML is a well formed format, or XML is actually well formed. What is well formed? Means XML is a case sensitive. Whenever you will start a tag, you should close it, otherwise it will become the parser will unable to parse it. Okay. So they are along with the advantages, these are some of the disadvantages, and that is why there are basically other techniques have been developed, like JSON, which we will talk about in a couple of minutes. So that is why XML, that is why basically other techniques are actually developed, or other file types actually developed, which is actually more popular these days in comparison with XML. But however, XML is a very powerful file type, and extensively used. If you just ignore few of the disadvantages, then it is a very powerful technology. Let's take an example of XML. This is XML. So it's a well formed. It should be well formed. Okay. So this is again about XML. This is a header, or you can say the first line in which we are actually defining that this is a XML document. Okay. So again, here you can see, other than this tag, you have to close any tag opened by you. So if you have a bookstore, I have closed it. If you have a book category, okay, I need to sorry, not book category, it's a book, it should be closed like this. Okay. If there is no body, because again in this tag there is a body, if there is even if no body, then basically we have to write this like, for example, if big store has basically some attribute but there is no body. Body means there is something in between open and close tag. Okay. In that case, even you have to write /. So anyhow, so this is a valid XML document. These are the attributes of this tag. And book tag has basically category attribute and cover attribute. Title has lang attribute, which is en, and there's a body. Okay, there's a body which is actually social media seeking. And similarly, author Chirag Shah. Again, there is no attribute associated with author tag, but there is a body associated with it, and so on. So you have one book category, you have another book category. Okay, so this is a well formed. If B is small, it should be small here as well. If you have somehow write capital B, it will become invalid document. So it is case sensitive, and basically it's in general you can say well formed, case sensitive. Every tag should, every open tag should be closed properly. Okay. After that, we have another format which is actually RSS, which is actually stands for really simple syndication. This is a very popular format to share data over internet. So if any website like to publish data to others, so that other can easily get updates about something, like maybe if you have a news website, if you have a company website, if you have a calendar website, or you have a calendar, or you have anything else, if you want to publish any changes you have done in your site, then you can basically publish using RSS. And it is very easy to, because RSS has its own schema. You can define your basically updates or your information in RSS form. Therefore, any RSS reader can easily and automatically read RSS content. For example, in news site, you might list news with titles, date, and description in RSS format. In company website, you might want to publish list of news and the new products. And in calendar, maybe you want to publish upcoming events and important days. And if you are talking about site changes, you might want to publish all the pages change with respect to the date and time. So all these information you can publish easily in basically RSS file format. Remember, RSS also uses XML. Just like XML, extensive markup language, which is again a well-formed language. Similarly, RSS is actually itself uses XML, but the difference is actually, or you can say, RSS based on XML represent data in the XML format, but RSS has its specific schema. So if you are writing or building RSS document, or you are basically creating RSS feed so that other softwares or maybe crawler or other basically other software like RSS aggregator, they can automatically read your published RSS document or RSS feed and and share with anyone who want to actually basically know about these updates. So it is really convenient, because if you are interested in maybe news, and there are multiple websites about news, so you have to manually visit each of them and to find out that what are the new news and what are the updates about the previous news and so on. But RSS make this thing very easy and very flexible. You just need to basically publish all these things yourself in RSS format, which actually uses XML itself, and RSS reader automatically read it. Okay. So the other way is basically you can register your RSS feed with RSS aggregator, like maybe Google RSS aggregator, or many other organization have basically RSS aggregator, so that your RSS feed will be available to a wide or basically a broad user base or a broad audience. Because if I am interested in basically news, I will basically maybe go, or maybe I will basically retrieve from RSS aggregator, and you have basically your own news website, so you have already registered with the RSS aggregator. So whenever I will go, I will basically somehow basically retrieve data from RSS aggregator. It will provide news from all news websites including you, because you have also subscribed your RSS feed with that particular RSS aggregator. So aggregators, you know what is actually aggregation? Aggregation is basically combining many things. So the role of RSS aggregator is to combine RSS feed from multiple sources. So if there are 4 news websites, all of them is actually subscribed with RSS aggregator, then whenever you publish something, it will be fetched by the RSS aggregator, and anyone which is actually subscribed with the RSS aggregator or basically searching on the RSS aggregator, it will get all the updates. Okay. So let's take an example of RSS aggregator. This is, again, if you can see over here, you will be like, sorry, this is actually an XML document. Yeah, it is an XML document, but mind it, here the tags are from RSS standards. All tags are from RSS standard. So this is the difference. RSS itself uses XML, but RSS has its own schema, and that is why, because of this standard schema, any RSS feed parser can parse any of the RSS document, or any RSS aggregator can parse any RSS feed. Okay, so this is an example of RSS. You have title, you have channels, you have description. So for detail, you can visit RSS standard website. How basically other people will know that you are actually publishing RSS feed from your website. Generally, you can write RSS or XML in orange tag or orange icon on your website, so that anybody can see and look or identify that you are actually publishing this important thing about your website in the form of RSS. So it is most of them are actually true. You can write just RSS in the orange, or you can write XML. So it indicates, it highlights that yes, your website is actually publishing your data in RSS and XML. So anyone, if you want to have, if anyone want to have update about your website, or anyone is actually interested in your content, will subscribe to your RSS, and he will be automatically aware that your site actually publishes RSS. Because if you are publishing RSS, but if you don't have this type of tag, how a person can know about it? How a software or how a crawler might know about it, that you are actually publishing your data in RSS format? So this is a way to indicate that your website publishes some important thing regarding your website in RSS format. Okay. So This is, you know it very well, they are a major search engine, and 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 and, and similarly they have basically their own aggregator as well, which actually aggregate RSS feed from various websites with respect to different categories. So let's move here. So this is all about RSS. Now, and again, the advantage of using RSS, just like XML, you can work with any programming language. If you want to work with any, if you want to work with XML or maybe RSS, because again RSS is based on XML, you can work with any programming language. Like you can work with Python, Java, C#, C++, you name it and you find it. Some parser to parse XML document. Okay. So now let's move to the JSON format, which is actually JavaScript object notation. JSON or JSON is a very popular file format, or you can say file type. It is actually a very efficient way to represent your data. Unlike XML, which is actually very verbose, that the payload of the data is become quite large, because due to this nature that everything should be enclosed in different tags. In many cases the size of the tags are much larger than the size of the actual data, and that is why it become very large in size if you are exchanging data over the network. So thanks to the JSON format, it is very flexible, it is very lightweight file format or file type to exchange data, not only between humans, or it is very easy to exchange between the machines, or you can say software as well, right? So most of the web applications are these days primarily or highly relying on JSON file type. This is another advantage of JSON. You can basically easily convert a JSON document into JavaScript object or a JavaScript collection. This is very advantage, or this is very powerful feature of JSON. That is why that is why JSON is really very popular. You can basically send any Java. If you are developing a web application, there should be some client side, there should be some server side. So if you want to exchange it between the server side and the client side, then it is very convenient to use JSON format. You can just store data in JavaScript collection and simply convert into JSON object and send it to the server side. No matter which language you are using at the server side, either C#, either VB.NET, maybe either Java, maybe Python, or maybe Ruby, any language, there is a parser available for JSON. So you can simply parse it at the server end, and you will get the collection in your specific programming language. Okay, and then again you will convert it and send it back to the client side. It will receive as a JSON object, and it will actually parse again to convert back into JavaScript collection. So this is basically another advantage of JSON. JSON is a very simple format. It actually contains two things: key and value. Simple, and by using this simple concept, you can represent as complex document as you want. Okay, how? You have just one. You just have basically key and value pairs. If value can be a single value, or maybe it is actually another document. Might be it may be a collection itself, like array. So key is a string followed by colon followed by some value, and value can be a single value, maybe an array, or maybe another JSON object. Okay, so in this way you can create a nested structure to represent a very complex data. Okay, so let's take an example. Let's move towards another example. See here, this is a valid JSON object. Okay, so have you defined key value, comma key value, comma key value. Here there are actually three attributes: name, age, state, and there are three values. You can simply convert again. You have defined like this. It is actually become a key value pair in JavaScript. You just need to basically convert JSON.stringify. It will convert this object into a string format, and you can simply send this object, which is in JavaScript collection format, into a JSON, and send it to the server side, which is actually using a PHP language. So once it will receive, it will parse and convert into its own collection. Okay, so this is the advantage. Again, once you will receive, you can just, if you have like this, if you have received like this, you can parse it. Okay, so you have both of the opportunities. If you have received a string in JSON and you want to if your server send a string in this format, there's a difference, by the way. You will be like, these two are same. No, this is not in double quotes. If this is not in double quotes, it is actually the syntax of JavaScript collection, which is key value pair collection. Key value, key value. So automatically it will create a collection obj. In obj there is a key name, there is another key age, there is another key state. So it will be treated like collection, but it is actually a collection, not a JSON string. But whenever you want to send it, you have to convert this object into string. So you have a function stringify, which convert this JSON collection into string and send it to the server side. Once assume you have received it, you will receive like this. Right now we are hard coding here to represent that it is a string because it is a double quote, and this whole string is a whole content which is very similar to this, but is actually contained in the string. So it will not be treated as a JavaScript collection, but it is just a simple string. But you know it very well that it's a valid document because it's a curly bracket open. Remember this, all JSON objects should start with curly bracket, should end with curly bracket. So there's a curly, it is actually a string because the whole JSON is actually in a string code. So now this is simply a string, but you know it very well that this string is a valid JSON document. Why? Because string curly bracket open, curly bracket close, key value, key value, key value, and so on. So if you just pass this string to JSON.parse, it will, if it is a valid JSON string, then it will convert into JavaScript collection, and it will similarly behave like earlier, that obj square bracket name will give you a John, obj square bracket age will give you 25, obj square bracket state will give you New Jersey as a value. So this is how basically JSON document is represented as the form of key value pair. Okay, so this is something about structured data file types. Remember, this is a structured data file type. It's structured because each file type has its own specific structure. No matter the CSV, TSV, XML, RSS or JSON. So now we have an idea about what are the common, most popular structured data file types and how it actually represents data. And in the end, I just want to reiterate that JSON is a very popular format, file format or file type these days, and most of the web applications are using or highly relying on JSON file type to send and receive data across the website or from client side to server side. With this, I would like to conclude today's lecture. In the next lecture, which is actually unit number 2.3, we will talk about data pre-processing. Till then, thank you very much.